Finding the domain of a composite function. As we discussed previously, the domain of a composite function such as f composite g is dependent on a domain of g and the domain of f. It is important to know when we can apply a composite function and when we cannot. That is, to know the domain of a function such as f composite g. Let us assume we know the domains of the functions f and g separately. If we write the composite function for an input x as f g of x, we can see right away that x must be a member of the domain of g in order for the expression to be meaningful, because otherwise we cannot complete the inner function evaluation. However, we also see that g of x must be a member of the domain of f. Otherwise, the second function evaluation in f of g of x cannot be completed, and the expression is still undefined. Thus, the domain of f composite g consists of only those inputs in the domain of g that produce outputs from g belonging to the domain of f. Note that the domain of f composed with g is a set of all x such that x is in the domain of g and g of x is in the domain of f. So, domain of a composite function. The domain of a composite function f of g of x is the set of those inputs x in the domain of g for which g of x is then in the domain of f. So, given a function composition f(g) of x, we want to determine its domain. First, we need to define the domain of g. 2, then we need to find the domain of f. And then 3, find those inputs x in the domain of g for which g of x is in the domain of f. And that is, exclude those inputs x from the domain of g for which g of x is not in the domain of f. The resulting set is a domain of f composite g. So for example 8, we're finding the domain of a composite function. We want to find a domain of f composite g of x, where the f of x is equal to 5 over x minus 1, and g of x is equal to 4 over 3x minus 2. Now, the domain of g of x consists of all real numbers except x, which is equal to 2/3, since that input value would cause us to divide by 0. Likewise, the domain of f consists of all real numbers except 1. So we need to exclude from the domain of g of x that value of x for which g of x is equal to 1. So how we're going to go about this? Here's step 1. Okay, we're going to first find the restriction on the function f of x, which is equal to 5 over x minus 1. And that restriction, we set the denominator equal to 0. So x minus 1 is equal to 0, so we know that x cannot equal 1. Now, there's also a restriction on g of x. So here we have the restriction on g of x, which is equal to 4 over 3x minus 2. We're going to set 3x minus 2 equal to 0. Solving for x, we get x is equal to 2/3. And again, because if I plug in 2/3 into this function, it's going to make this undefined. If I plug in 1 into this function, it's going to make it undefined. So, in step number 3, the restriction on f composite g of x. Well, what we need to do is, we're going to set the function g of x equal to the restriction on f of x. So, what do we know g of x is equal to? Well, we know that g of x is equal to 4 over 3x minus 2, and it's going to equal the restriction on f of x, which is equal to 1. And then what we want to do is, we want to solve for x. By solving for x, we can multiply both sides by the LCD, which is 3x minus 2. Okay, on this side, we can eliminate the 3x minus 2, which we're left with 4. And this is 1 times 3x minus 2, which is 3x minus 2. Then what we're going to do is we're going to add 2 to both sides, and therefore 3x is equal to 6, and now x is going to equal 2. So, in step 4, the domain of f composite g is a set of all real numbers except 2/3 and 2. So this means that x cannot equal 2/3 or x cannot equal 2. And now that we have this information, we can write this in interval notation. And the best way to do that is just graph. Well, we know that all the numbers from negative infinity to 2/3 can be included, but we can't include 2/3. We can include all the numbers between 2/3 and 2, but we can't include the 2. And we can include all the numbers from 2 all the way to infinity. So if we write this in interval notation, we go from negative infinity to 2/3, parentheses, union, 2/3 to 2, parentheses, and then union 2 to infinity.